Hi everyone, Pauline here. This is one of the questions from week 5. It's the parabola question. And in this question, we're talking about the locus of the point P, which travels such that it is always equidistant from a point, okay, and in my case, let's say it's 0, 5, and the line y equals 2. And we want to find the equation of the normal to y equals p of x at the point A, 3, and then p of 3, okay? So what we want to do is start by drawing this locus, and we'll mark 0, 5 and y equals 2. And all of the points in the locus are equidistant from 0, 5, which we'll call the focus, and y equals 2. So we can begin by marking the point directly between the focus and the line, right? And then we might venture a bit further out and find points that seem about right, and each time we'll say that the distance between the focus and the line are the same. So how do we define each of these points? Well, you might recognize the shape. It's looking a lot like a parabola, and what we've been given is the geometric definition of a parabola, which is the locus for points equidistant from the focus and the directrix. So to make this easier to think about, let's shift our parabola so that the vertex is on the origin, and it's like putting the x-axis here, but to avoid confusion, we'll draw it again and we'll shift the focus and the directrix accordingly. So what do we know? Well, we know that each point xy is equidistant from the focus and the directrix. So if we draw a right triangle here, one of the side lengths is the x value of the points, right? And this side length here is the y value minus, and here we'll use the general form. If the focus is a distance a from the vertex, and here a is 1.5, then this length here is y minus a. Also, we know that the distance from the point down to the directrix is y plus a, so that's the same as the distance from the point to the focus. So let's plug all of that into Pythagoras, and we'll expand the brackets and tidy that up. And we end up with x squared equals 4ay, which is the standard form for a parabola with the vertex on the origin. And in our case, a is 1.5, so we know that x squared is 6y, and we'll turn that back around, y equals 1/6 x squared. This parabola is congruent to our original parabola, but we shifted it down to sit on the origin. So our original parabola has the same form, but we need to move it back up by 2 plus 1.5 is 3.5 units. So y equals 1/6 x squared plus 3.5. Now what we want is to find the equation of the normal when x equals 3. So we'll begin by finding the gradient of the tangent, and we can do that by differentiating the equation we just made. dy dx equals 1/3 x. So we'll sub in x equals 3 into what we've got, and we see that y equals 1.5 plus 3.5 equals 5. So the point of contact is 3, 5, and the gradient of the tangent is, when x equals 3, the gradient is 1. The normal is perpendicular to the tangent, so we might just draw that. We've got a tangent with some gradient, rise over run, and we'll draw a line that is perpendicular to that one. And it's like we've turned the whole triangle by 90 degrees. So we've kind of swapped the rise and the run, except that we need to worry about the direction. So if you look at the normal line there, and you head up from the lower right to the upper left, the horizontal bit is actually heading in a negative direction. So while the lengths are the same as the rise and the run from before, this bit here is negative. So if the gradient of the tangent is rise over run, then the gradient of the normal is kind of run over negative rise, which is basically -1 divided by the gradient of the tangent. So here we have the gradient of the normal is -1 over 1, which is -1. So now we have a line passing through the point 3, 5, and with gradient -1. So that's y minus 5 equals -1 x minus 3, and so y equals -x plus 8. The next part of this question is saying that the normal also meets the parabola at point B. So we have the equation of the parabola, and we have the equation of the normal, and they will meet wherever a point satisfies both equations. So let's say that the y values are equal, and therefore 1/6 x squared plus 3.5 equals -x plus 8. So we'll multiply through by 6, and then tidy that up and factorize, and we end up with x equals -9 and x equals 3. We already knew about x equals 3, right? So this time we'll find the y value for x equals minus 9. And I'm lazy, so I'll just do it for the normal. And y equals minus x plus 8, so y equals 17. Now the last bit of this question asks how long the chord AB is. So let's draw that. And again, we'll use Pythagoras, and these side lengths we can tell are 12 units wide and 12 units high. So the length of the hypotenuse is 12 root 2, which is 16.971, but we want it just to 3 significant figures, so it's 17.0 units long.